I wanted to show you some problems that I forgot to put an example of earlier. And it'd be a problem like this, where if they give you some vertices of a couple of triangles. So we're going to have one triangle called PQR, and they're going to give you coordinates for those of 3, 4, and for Q, 2, 2, and for R, 7, 2. And then a second set of coordinates for another triangle, and that triangle is going to be called STU. And let's say that S is given to you as 6, -3, T is 4, -2, and U is 4, -7. Okay, so if we take these and we plot them out, you're going to kind of see that these are going to make some triangles. And the idea here is to determine if triangle PQR is in fact congruent to triangle STU. Okay, so if we plot them out over here, let's see, we got 3, 4 is right there, 2, 2, 7, 2. So there's P, Q, R. Okay, and then our second triangle STU has sides of 6, -3, 4, -2. That's S, that's T. And our third vertex is vertex is 4, -7. All right, now, in order to show these are congruent, okay, it's not enough if you're just going to say, oh, yes, I can tell just by looking. Okay, I want you to prove it. And in order to prove it, we're going to use one of our shortcuts that we learned. We're going to use the shortcut SSS, because I can determine on my picture here the lengths of all 3 sides of each triangle. So we're going to do that, and you could feel free to use your calculator, the distance program in there, but you're going to have to find a bunch of distances here. We're going to have to find the length of PQ, the length of QR, the length of PR, and we're going to see if they're going to match the corresponding sides on the other one. If I look at my picture, PQ looks like it's supposed to match TS. The QR side looks like it's going to match the TU side. And the PR side over here looks like it should match the SU side over there. Okay, so if you, and I'm not going to bore you to death with putting in all the numbers here, but some of this, like QR, for example, you don't even need a calculator for. On the graph, it runs perfectly horizontal, and it's 1, 2, 3, 4, 5 units long. So that one's 5 units, and what do you know? 1, 2, 3, 4, 5 units long for TU. So both of these so far are a match. And we want to go through and do the same with these other ones. Okay, so I'm going to try to do some of these quickly on my calculator. Let's see, for PR, if you were to put those coordinates in your distance formula, let's see what you get. For that one, you should get about 4.47 approximately. Okay, and SU, I guarantee you're going to get the same thing. I can see that this one goes 4 over and 2 down, and that one goes 4 down and 2 over. So they are guaranteed to have the same distance, I guarantee it. But it's about 4.47. Okay, and then on the last pair of sides, let's see, this one goes over 1 down 2, over 1 down 2, like that as well. So both of those should come out to about 2.24, if you round that to the nearest hundredth, 2.24. So again, a match on both of those. Okay, so when you do these problems, I just want you to put the coordinates there into the distance formula in your calculator and find the distances and show me that they match. And if you get all 3 pairs matching, we can say the triangles are congruent, and we can determine it by SSS, that shortcut. So use that on problems. Let me look here. It was, I believe, problems 20 and 22 on page 210.